Alright, this is the notes for section 1-4 geometry. If you haven't done so already, make sure that you take a few minutes to read the section before you continue on with this video. This section is about undefined terms and first definitions. So as we think about what we're going to be doing with this course is we're going to be basically developing the rules of geometry. And just like if you were looking at other topics such as law or economics or games such as golf or baseball or softball, you need a set of rules that are clearly defined and have no ambiguity towards them, so that anyone that's playing the game can play by the defined rules of that game, or anyone that's in court knows what the rules of law are. Well, the same thing applies for geometry in that we need to have very precise definitions. However, there are some terms in geometry, just like there are in other areas as well, that we purposefully leave undefined. And the reason we leave them undefined is because of circularity. This idea that in order to define it, we just will keep going in a circle. So a point is a spot is a place is an exact location, and an exact location is a point. So we kind of keep going around in a circle. Well, the three terms that we're going to leave undefined in this book are point, line, and plane. Okay? So keep in mind that's going to be something that you're going to need to know, that we're purposefully leaving these three terms undefined. Okay? Now, we will also use those points in other definitions. So down here I have 5 different definitions, definitions you're going to need to be familiar with. And that is figure, space, collinear, plane figures, and coplanar. Okay? And all of them use either point or line or plane or a combination of them in their definitions. So if I look at a figure is a set of points. Okay, that's kind of an interesting definition of figure, but that's as exact as we can be with that particular definition. So any set of points put together make up a figure. Okay? Space is all points. Now these two terms, collinear and coplanar, are going to be very important, and those are the ones that are difficult for a lot of students to comprehend. The idea of collinear is when we're talking about 3 or more points that lie on the same line. Now, don't get caught up in the 3. The only reason why we're saying 3 is because really in Euclidean geometry, any 2 points determine a line. Therefore, we say 3 because that 2 is somewhat irrelevant. Okay? So when you think about collinear, think about it as being points that are on the same line. Okay? Coplanar, you can think about as being points that are on the same plane. So if you think about any flat surface in space, points that are on that flat surface would be considered coplanar. Now normally we'll talk about coplanar as being 4 or more points. In fact, I think on your note sheet we have 4 points there. And the reason for that is really any 3 points would lie in the same plane. And we'll talk a little bit more about that as we look at the point, line, plane postulate. But coplanar really is points lying in the same plane. Now the last definition I haven't talked about is plane figure. And a plane figure is just a set of points that all lie in one plane. So if you think about a figure, basically we're taking a figure that lies in a plane. Okay. So what I'd like to do now is I'd like to take a look at an example problem. An example problem I have outlined right here on your notes. When we do that, before we start the problem, I'd like to take a look at this picture over here. And I want you to think about this picture as being a 3-dimensional picture. So if you think about it as being like a house, there's each face of the house you can think of as being a plane. So this front face where the door is a plane. This part of the roof here is a plane. This side wall is a plane, etc. So any face of the house kind of all lies in the same plane. Okay? And if you think about the figure, the edges would be line segments. Okay? Therefore, points on the edges are going to lie on the same line. So here's what we're asking. We're really getting at those definitions of collinear and coplanar. And what we want to do is we want to say, all right, let's see if we can name 3 sets of collinear points. Okay, when we do that, we want 3 collinear points and 3 sets of 4 coplanar points. Okay, so let's talk about the collinear ones first. We're talking about points that lie on the same line. So a good example of that would be this line right here. And as you look at that line, whoops, moved on me there. As you look at that line, E, I, and D are all on that same edge. Therefore, we would say that those points are collinear. Okay? So would F, J, and G. They're all on the same line. Therefore, we would say they are collinear. Okay? And we're looking for 3 sets of collinear points. So another set of 3 might be down here. Actually, all 4 of these lie on the same line. So any 3 of those would work. So we could say B, K, and L. So there's 3 sets of 3 collinear points. Now if we talk about coplanar points, we're talking about points that are on the same plane. So I'm going to start with this front plane, and any one of these letters, A, E, I, D, C, L, K, B, M, and N, all of those are on that same front face of the house. So any 4 of those combined would meet one of our sets. So let's just say A, E, D, and let's pick one on the bottom. Let's pick L. Okay, that would be a set of 4 collinear points. Now next I'm going to move over to this side face over here, and D, C, H, and G kind of define that side face. So let's use those 4 points. They would all lie in the same plane. D, C, H, and G. Okay. A third set of points, I can come up to the roof up here, and there's 6 points up on this roof, E, I, D, G, J, and F. And you'll notice that some of these lie in more than one plane. That means that's where the planes intersect. We'll talk a little bit more about that as we move through this course about intersecting planes. But let's just pick any 4 of those. Let's say E, I, G, and D. And that would represent 4 coplanars. So these are coplanar, planar ones here, and these are collinear. All right, now that we've defined collinear and coplanar, that's going to allow us, actually, and figure as well, it's going to allow us to define dimensions in geometry. We know that we live in a 3-dimensional world, but we can break those 3 dimensionals down, and let's just say that we lived in a 1-dimensional world. Well, 1 dimension in geometry means that all of the points would all lie on the same line, or they would all be collinear. Therefore, we define 1 dimension as a space, a type of geometry or figure in which all points are collinear. If we're talking about 2-dimensional, we're talking about a type of geometry in which all points are coplanar. Okay? We're going to spend a good portion of this course really just looking at 2-dimensional geometry, where everything we can draw on a piece of paper on a plane. So that means that all the points in 2-dimensional geometry are coplanar. And the third dimension is when we look at a type of geometry where a figure in which all points do not lie in a single plane. So once we look at 3 dimensions, that means that it's going to operate more like our current world does, in that everything is not all points lie in the same plane like they do in a 2-dimensional world. Okay? What I'd like you to do before you come to class next time is see if you can do the problem at the bottom of your notes here. Classify each figure as 1, 2, or 3-dimensional, and then we'll talk a little bit about that when you get to class next time.